Hey guys, so previously we have been talking about the chemical reactions of hydrocarbons. We know that alkanes give the substitution, alkenes give the addition. We know that combustion is common to both. And then we drew some attention on the complete incomplete combustion. We wrote some equations for those. Then we even talked about the substitution reaction, which requires the ultraviolet light, and substitution was only for the alkanes. In today's video we're going to be talking about the addition reactions, and we're going to see how they are only exclusive to the alkenes. So we're going to be talking about addition reactions. We're going to see that these are exclusively for alkenes. Exclusively for alkenes. Like we have a tradition of underlining this part. So alkenes, not for alkanes, okay? Here what happens actually is that the carbon-carbon double bond breaks down. The carbon-carbon double bond breaks down and two new bonds are made. So essentially you are breaking a bond within the alkene molecule and you make two new bonds with some perhaps new atoms. Like let's try to understand this idea. For example, you have a propene molecule, 1, 2 and 3 carbon over here with a double bond, right? Double bond could be anywhere. It could be between the carbon 1 and 2, it could be between 2 and 3. I have a double bond and I have all the hydrogens over here, which are enough to perhaps make 4 bonds for each carbon. So these are my carbon to carbon double bond. Now if I want to perform the addition of chlorine, if I do the addition of chlorine, let's suppose I provide chlorine molecules and let's call it the addition of chlorine. You just make sure that the carbon-carbon double bond is here between the center carbon, between the carbon on the center and the carbon on the right. Over here, as a product, you do not change anything about the reaction, just you make sure that the double bond is gone. You remove the double bond, all the hydrogens are still over here. These were the hydrogens previously. As it is, they came over here. These carbons had the double bond, so I'm just highlighting them to showcase that these are the carbons which had the double bond. And you make two new bonds. You have removed the carbon-carbon double bond. There is no double bond over here now. And you make two new bonds with two new chlorine atoms. It is totally okay for the double bond, for the chlorine atoms to come on these carbons in any direction. You can be having them one going in the upward direction, one going in the rightward direction. All what matters is that one chlorine is added to this carbon and the other chlorine is added to this carbon. Now it could be in any direction. You don't care about the direction. The only thing that you care about is the fact that one chlorine is attached to carbon 1 and other is attached to carbon number 2, the ones which had the double bond. Let's try another example. Let's suppose if I'm making the addition of bromine. Let's suppose I'm giving this color because let's suppose bromine, right? Over here. Addition of bromine. Now you do the same thing. You draw your 3 carbon molecule like this. 1 carbon, 2 carbon, 3 carbon. You make sure that the double bond is gone. Previously you had a double bond, but after addition reaction there is no double bond. I'm just highlighting the carbons. You draw the hydrogens as it is. So this is the first hydrogens. These 3. A hydrogen over here. These 2 hydrogens over here. You make sure you draw 2 bromine molecules, 2 bromine atoms I should say, one over here, the other over here, and you are done with the product. In the addition of chlorine, you were making 2 chlorine atoms on both carbons. In the addition of bromine, you are making 2 new bromine atoms on both the carbons, and that's it. You do not change a single thing about the molecule except just a double bond is gone. I'll put this a little on the other side over here, and now we have one more case. For example, if I want to perform the addition of hydrogen, which is another possible scenario. If I'm talking about the addition of hydrogen, right? In addition of hydrogen, you have 2 new hydrogen atoms which are supposed to be added. So in addition reaction, you draw the same structure without the carbon to carbon double bond, 1 carbon, 2 carbon, 3 carbon. The hydrogen atoms which were previously here are still here. These three hydrogens, one hydrogen in the carbon in the center, these two hydrogens over here, they're still here. Let me just push it over here. Yeah. Now what you do is you get two new hydrogen atoms. So one hydrogen atom comes on this carbon, the other comes on that carbon. The concept is that when the double bond is broken down, both the carbon have the capacity to make one new bond each. So both the carbons try to make new bonds. They had a double bond, they broke it down, and now they want some new atom to join them. So each carbon invites a new atom. Sometimes they invite two chlorine atoms, sometimes they invite two bromine atoms, sometimes they invite two new hydrogen atoms, and that all depends on what you are supplying them with. Similarly, like over here, you have two new hydrogen atoms. So double bond breaks down, and every time you get two new atoms joining these carbons. For example, let's try one more example. If it's a complicated molecule, let's say like this. I'm making a complicated molecule just so that we can understand the whole concept. There are three hydrogens over here. There's one hydrogen over here. It's a branch. I can see that it is a branch because it is not all the carbons in the straight chain. And I have one hydrogen over here, I have two over here, and I have a carbon to carbon double bond towards the right side. If I want to perform the addition of bromine, let's suppose if I make it react with bromine, let's call it the addition of bromine. What happens is that you keep the entire structure intact without the carbon-carbon double bond. So the carbons stay over here like this. 1, 2, 3, 4. The branch comes like this. You have a branch over here. Your hydrogens come exactly in the position, the previous hydrogens which were already here. You make one line for each bond. You have that hydrogen, you have these two hydrogens. Double bond is gone. The double bond which was previously over here, let's use some other color to highlight it. The double bond was over here and the double bond is gone. Now you get two new bromine atoms. It could be in any direction. You can make one bromine atom going upwards because the structure looks more clear, more simple this way. The other bromine comes here. These carbons had the double bond, now these carbons have the bromine atoms. Simple. You don't care about in which direction the bromine is going. All you care about is the fact that both the carbons get one bromine each because they had the double bond, and now they need something to compensate for the lost double bond. Let's try one more example. Within the same molecule, we are gonna be working with hydrogen. So if I want to perform the addition of hydrogen like this, addition of hydrogen, where in addition of hydrogen, we just make two new hydrogen atoms, which is not kind of surprising because the molecule already had a lot of hydrogens. There are 4 carbons. There's a branch carbon. The red ones are the older hydrogens. It represents the hydrogens which are already there. So you have these hydrogens over here already. These hydrogens are right over here. This is the branched carbon. It had the hydrogen over here. This was the carbon which had the double bond. And now you make two new hydrogens. So one gets over here, the other comes over here. These carbons had the double bond. Now these carbons, the same carbons, have two new hydrogen atoms each, and that is just one bond each. So you simply get two new hydrogen atoms. So when we write the equation for it, for example, let's try an example. Initially we did propene, right? So propene is C3H6. It's an alkene. It's propene. If you perform the addition of bromine, let's suppose if it's a addition of bromine, you're not removing anything, you're just adding two new bromine atoms. So you keep the number of carbons same in the product. Even there's no loss of hydrogen, you are not even losing a hydrogen over here. But you get two new bromine atoms, so it becomes this. It's an addition reaction, right? So in addition reaction you don't lose anything. You just add new stuff. So it's not loss of any hydrogen. In substitution, you used to have a leaving hydrogen, but right now there's no leaving hydrogen. You just add two new bromine atoms. Similarly, if it was butene, for example, C4H8 was butene. If you do the addition of chlorine, what you do is you don't remove anything. The number of carbon remains the same, C4. The number of hydrogen still remains the same, H8. But you get two new chlorine atoms joining it because the double bond was broken down and each carbon gets one chlorine. So as a whole, the entire molecule gets one chlorine each. For example, if it was C4H8, which is again butene, and it reacts with hydrogen in addition reaction, it's addition of hydrogen. So what happens is addition of hydrogen. What happens is that you keep the number of carbons same, you keep the number of hydrogens same, but you notice that this is two new hydrogens coming in, and already you had 8 hydrogens. So essentially it becomes 10 hydrogens, and now it's not C4H8, it's C4H10, and essentially the two hydrogens have joined the whole molecule. So you don't see any difference between the hydrogens which were previously there and the hydrogens which are incoming. So you get a butane, C4H8, C4H10 was actually butane. So after addition you actually got butane. Let's try one more example before ending this video. If it was C5H10, which is pentene, and you do the addition of hydrogen over here, so you're supposed to be getting two new hydrogen atoms joining it. What happens is you get C5 and H12 because this time you're adding two new hydrogen atoms. In addition reaction, the double bond broke down, and now it's not pentene anymore, it became pentane. So through this series, the pentene became the pentane. The butene after the addition of hydrogen became the butane. So let's keep that in mind, that in addition reaction the double bond is broken down and you get two new atoms on those very carbons, on those same carbons which are losing their double bond. In the next video we are going to be talking more about the addition reaction, and we're going to try more on the catalysts needed for those reactions. So stay tuned, guys.